I don't know. Just kind of comes through. What is up, Pre-Cal 12? It's Coach Jay in second period. We're getting lit. We're going to finesse today. And isn't that right? Is that how we use this?
Yeah.
How you use it? Okay. Well, we'll just go with it. So we're going to get rolling. Hopefully you're taking good notes, and we're going from there. Okay? Is that right? Did I use that right?
I think
We're lit.
that's how I use it.
Whatever. I don't know what the word is today, but we'll keep it going. All right. So as we begin, a lot of these are pretty quick. Let's see if we can kind of just get our feet wet on what we did before in section 4. I think it was 4.3, and we're just going to kind of keep ourselves going off the notes and then also into the homework as well. Hey, someone help me out. What is 1 over cosine? Just raise your hand as we go, Madeline. Secant. Good. Let's do. Well, what would be 1 plus what is cosecant squared? 1 plus what, Jackson? Yeah. Yeah, 1 plus cotangent squared, right? This would be cotangent squared of x is equal to cosecant squared of x or u or whatever we're talking about for that variable. Good. What is cosine of pi over 2 minus u or minus x? Michael?
It is
Sine of u, right? Do you ever remember we talked about this, right? I think we've already discussed these down here. We kind of showed them why they are what they are. And now I'm assuming that you kind of already have a little bit of understanding. And now it's simply not memorizing these. It's just using them, okay? Just using them. Harrison, what would be 1 plus tangent squared equals what? Do you know?
Cosecant squared x or u.
Not
Wait,
quite.
no.
1 plus
Never mind,
cotangent
never
squared.
mind.
You're right. You're 1 plus cotangent squared.
Oh, you go secant squared.
Secant squared. Good. Okay. Worst conference in America. So secant squared of theta is what it would end up being equal to with 1 plus tangent squared. Okay. What is secant of pi over 2 minus u? Good work. Madeline, got another? Cosecant. Good. Yeah. So we've got cosecant right down here on that side. And what's cosine of negative u? Someone else know that hasn't got one yet? Cosecant of negative u? Roll, do you know?
Cosine.
Oh, cosine of negative u, I'm sorry.
Cosine.
Right down here, right? These are these odd and even identities. And if we see cosine of negative u, it's equal to,
Okay. I mean, it says that at the top, so that's why I said that.
oh, right here? This one? Correct. If I said cosine of positive u, you'd be exactly right, which is actually technically true. Because look right here, cosine of negative u is cosine of u, which if you really jumped ahead, depending upon the problem, is also equal to 1 over secant of u, okay? All right, questions on that? All right, so any of those, do y'all struggle with using this gray sheet right here and manipulating it to get over here? Y'all feel okay with that? Okay. All right, so let's just have a couple of questions, Q&A here. What would I do? What would I look to in terms of identities if I saw something squared, sine squared or cosine squared, and I needed to simplify? What would I automatically go to, Jackson?
Pythagorean identity.
Good. If I looked at something squared, I'm always going to look towards the Pythagorean identities. That's where my mind should go to. Not all the time, but a lot of times. I'm just going to see if I'm able to simplify using my Pythagorean identities. Good. All right, so here's one for 3 tickets. You ready? All right, I'm going to make one up. You got to kind of listen, because I'm not going to write it down. What would be secant squared u minus 1? What would it be equal to? Someone raise your hand and tell me. Secant squared u minus 1, what would it be equal to? Trying to look for someone else who hasn't gotten one yet today. Secant squared u minus 1. What would it be? Jeffrey, you know?
Tangent squared.
Money, yeah, because how'd you do that?
Just subtract 1.
Yeah, just subtract 1, and once I do that, I would get tangent squared equals worst conference in America minus 1. Question?
Could it not be negative cosine squared? At all.
How'd you get negative cosine squared?
Subtract 1. Oh wait.
Well,
Oh, never mind.
big 12.
I see why. I see what you're saying.
I was
Yeah.
Just forget that.
Okay, it's all right. I got you. We'll forget. We got that. Right on. Questions on this? Rocking. Okay, so here's the thing. As I go through these next few, I will be honest, it becomes a little tricky. Okay? The tricky part about this is what strategies am I going to use? So before we go into kind of section 5.2, we're going to look strictly at strategies. That's it. Okay? What are some strategies? So sometimes I'm going to ask some questions that are going to feel like, man, this looks really hard. And you may throw out something that may not be exactly right, but I just want you to start thinking and engaging, even if you're not maybe right the first time.
You
Okay?
miss every shot you don't take.
That's exactly right. It's good stuff
And then
right
you
there.
miss most of the ones that you
Cool. That's not true. All right. So let's look at this first one, okay? Again, we're finding ways to simplify. So as we find ways we simplify, we're trying to get this to go from where it is right now to maybe a more simple version of where we're headed, okay? All right, any thoughts on what we can do to maybe start the simplifying process? Roll, go ahead.
Add side to whatever the other side is.
I actually like that. I do like that. Here's what I would say to this right now for today, and really for the remainder of 5.1 and 5.2. We're going to, when it's set equal, whatever it is equal to on this side, which we don't know, we're actually going to freeze one side. I was very lenient on that the last test we did this on, but we're really going to freeze the left side, because technically that's what we do within math when we prove something. We freeze it to get to whatever is equal to the other side. So, Roll, I like what you said there. We're actually going to freeze this left side, though. Okay? Good thoughts. Mathematically, you're right, but for this, we're going to keep that left side. Any other thoughts? All right, so watch this. This first one, okay, operates as sine, cosine squared because they're multiplied, right? The second one is sine. Question for 2 tickets, can you tell me what I can do to maybe take something out of this, and what would that look like, Michael?
Can you like combine like terms and then take the sign?
That's actually a good thought. I can't combine them because this one, because they're multiplied, is different. It's not a like term compared to sine. Good thought. Anything maybe different? What can we take out? Here's a hint.
The square.
Close.
Oh, what's it?
Oh, sign and
Oh, the thing where you take it out. Oh, God, it has a name though.
Greatest common factor. Got me? All right, so, and I've got a rap coming called Teach Me How to Factor. Teach me how to factor. Got me? It's coming. Release will be soon. So when I take this out, I'm going to be taking out a sine of x, okay, because that's what's in common. And because of that, what is left over on the inside?
Cosine.
Good, nicely done, Noble. Cosine squared of x minus 1. Why did you just hold on to that 1? Why did you keep it as 1 and not 0?
Because you can't just throw sign away. It's not nothing. It's 1.
Yeah, because we divide it. It's not, it's not by itself. It's just simply the answer of 1. Good. Okay. Let's go to different colors. Step 2. Any thoughts of how we could continue to simplify? This is good. This is good stuff. Noble with the second thing here.
Well, you can subtract the 1 on the identity, so you know that equals sine squared.
All right. So sine squared. This is the identity. I just want to show people. I hear what you're saying. This is the identity down here, down yonder. What can I do to get cosine squared minus 1 down here?
You just gotta subtract the 1. Or no, subtract the 1.
Okay.
Add the sign over.
Subtract 1. Now this is a little bit different. I get then sine squared of x plus cosine squared x minus 1 equals 0.
But then move the sign over.
Good.
And it'd be negative sign.
Good. So because of this, when I subtract, are y'all following me right now? When I subtract this, I get cosine squared of x minus 1 is equal to negative sine squared. Sorry, Jackson. And because it's negative sine squared there, right? Can y'all see that on that
Yeah.
part?
No.
Or you can't see it?
No.
Just yell at me. Just yell at me. My fault.
Ah,
Thank you. So we get cosine squared minus 1 is equal to negative sine squared. Okay? All I did was change around that identity to where I get what I have up at the top, okay? So Claire, what would I plug in for cosine squared minus 1? I asked you because I wanted to make sure that my writing was clear, my fault. So do you see how I changed this? This was the identity, right? Bingo, bingo. That literally will be plugged in for this part up here, okay? Good. Now, can I simplify this one more step? Can I go one more step? What would I do? What would it be equal to? Cubed, because there's 3, right? So we would say this is negative sine cubed of x, and that is what the top would be equal to. Okay? All right, questions on that? Good stuff. Okay, let's go to the next one. All right, this top one is now we're starting to verify these identities, okay? This is our kind of our next example. We're going to try to match one side up to the other. What is the side that we're focused on trying to match up to the other side? The left, because it's the most difficult side. Like Claire said, traditionally, the left side is what we change. So we're going to change the left side, and we're going to freeze the right side, okay? All right, here we go. Let's get some major tickets going here. I will give, I got some good tickets. Tell me a strategy. It could be right, might not be, but just some thoughts on how you would start it. Claire?
Could you make the cosine over sine?
You know, that's really good. I like that. You could change the cosine over sine to tangent, or cotangent. I would tell you, because we did it last class, I tried it, it actually makes it tougher. Now, here's the thing. There's going to be times where you're going to do that. You're going to go, and you're going to try it out, and then you're going to hit a brick wall, and you're going to say, man, was I wrong? No, you're not wrong. There's just sometimes easier ways to do it. And really, it just depends on just trying it and seeing where it goes. But, Claire, you're exactly right. That's good. Madeline, do you know?
Could you change the denominator to sine squared?
Right here?
Yeah.
You know, that's a good thought. Why can we not in this instance? You know, Chet?
You can have a squared on the
Come
bottom.
back to you for that. Yeah, it's got to be what? It's got to be squared, right? That's a really good thought. Just be careful. We can't use Pythagorean identities unless it's squared. Okay? Great thought there. Jay, do you have another idea?
Did you cancel?
Great thought. Yeah, I got that the last class too. Why can't I cancel here and here?
They're not multiplying.
We're not multiplied, we're added. All right, so here we go. This is the strategy. Go ahead. You know?
Can you multiply? Can you get the same denominator?
Bingo. Yes. 4 tickets. That's nicely done. Same denominator because we're adding
I know how to do this.
fractions. Go roll. Take it. Go.
You multiply the sine of 1 plus cosine by sine top and bottom.
We're gonna multiply because this is missing a sign, right?
Right.
Everyone good?
Other one you're gonna multiply by the denominator 1 plus cosine.
Yep. Because this is missing 1 plus cosine, I'm gonna multiply that top and bottom. Okay.
Right.
Again, we're freezing the right.
And then you combine like terms on the left side.
Cosine of theta, yes. Okay. And what I'm going to do, I'm going to rewrite this because it looks really messy. What's sine times sine? Sine squared, and I'll put it right up here. Okay, sine squared theta. What's cosine times 1? Cosine of theta. Cosine times cosine is?
Cosine squared.
What did I just do? 2 tickets if you know. What did I just do with this?
Distribute.
Distribute it. Yeah. Good. Job roll. And this is all over what?
1, no. Sine plus cosine.
1 plus cosine theta plus sine.
And it would be multiplied, right? But other than that, Claire, you're right. So we would say sine of theta times 1 plus cosine of theta. How many of you think that looks really weird? A little weird? I agree. All right, so here's the thing. Sometimes this is going to look strange. It is. It's going to look strange. Trust the process, though. We see 2 fractions, okay? We get common denominators. We simplify. That's where we're at right now, okay? It looks just really complicated. However, I see that there's a sine squared here, and I can look and see that there's possibly a Pythagorean identity. Can someone help me with what I could do to maybe push forward and simplify? Mike?
Add the 2 cosines for each bit.
Yeah.
You can add sine squared plus cosine squared, you get 1. So that'd be
Good.
1 plus cosine.
Yeah, so do you see this here, right up here? Sine squared plus cosine squared is what, Harrison? Do you know what sine squared plus cosine squared would be? I didn't mean to put you on the spot, dude. I'm sorry.
1.
It's 1. Nicely done. So what would be the top now?
1
1
plus
plus cosine.
1 plus cosine of theta all over, and then I'm just going to rewrite what I had. Sine of theta times 1 plus cosine of theta on the bottom. They do because it's the exact same thing, right? Now, if this was 2 plus cosine, I couldn't cancel this. But because this is being multiplied, these cancel, leaving me with what?
1 over sine theta, which equals the other side.
Which is cosecant, right? And there you are.
Wow.
I actually like these once I get confident enough to be able to do them, okay? The biggest thing, I know Jackson, a couple of you raised your hands and said, yeah, this is kind of weird. But trust that this is actually going to be true, and you're just trying to show me how to get there, okay? That's really the big picture here, okay? All right, let's do a couple other tickets. These are just, again, strategies spiced in with some verifying problems. Secant squared minus 1. That's a little weird. What if I said that, hey, factor this? How would I factor it? 1 over cosine squared, we could. Okay, if we were simplifying, that could be a part of it. But what if I said, hey, just factor it? Don't have to simplify, just kind of factor it and leave it. What would be a way that we could actually factor secant squared minus 1? Well, do you know?
Secant times what equals? I'm trying to figure out what we can pull out.
Could I try something, and I'm going to come back to you, okay? Take out secant and put x in. And then we'll put it back in at the end. So instead of secant, because that looks weird, what if I said roll x squared minus 1? How would you factor x squared minus 1 if I replace secant with x? Perfect. X plus 1, x minus 1, you rock that. And then once I factor that out, if you need to do this, go ahead and put x in for secant. And then because of difference of 2 squares, we say x plus 1, x minus 1. Are y'all good on that? I know I'm kind of assuming with the factoring thing. We could take the square root of both with the minus in the middle, okay? And we put what back in for x to then finalize this? So we could say then this is secant of x plus 1 and secant of x minus 1, and that would be how we would factor this, okay? Good stuff. Good stuff. That gives you 1 for that roll. Y'all are rolling in the tickets. I love it. All right, look at the next one here. I'll be honest, this next one's tough. Okay, I'm going to kind of rise up. All right, there we are. Good. Okay. Do you like that? It's cute. All right. Falcons rise up. Well, yeah, when your defense gives up 40 points, it's not a whole rising up that they're doing right now. Just so you know. All right. For tangent squared plus tangent minus 3, this is part B now. Okay? It's a little tougher. Again, what I would do, put x in for tangent. Okay, so let's do that first. 4x squared plus x minus 3, where x is equal to tangent. We'll put this back in once we're done. How many of you do the check and guess method? How many of you do the A times C method? How many of you have no idea what I'm talking about right now, and you're just kind of like, okay. How many of you struggle with, well, let me backtrack. If I had x squared plus 6x plus 5, could you factor that?
Yes.
Right? X
Oh,
plus
HC
2,
method.
x plus 3, right? But when this a value is greater than 1, it
Yeah,
becomes
that-
tricky. You don't like that?
You make the box, don't you?
I do this one. A times C method?
Yeah,
Thing?
that makes
Perfect.
sense. That makes sense.
I'm going to do that. I like that better. I like that better.
Right, and then you- right.
All right, so I'm going to show you how to do A times C method, okay? All right, here we go. A times C. So A times C is 4 times negative 3, which is negative 12, okay?
Yeah.
Yeah, kind of the slip and slide you
Yeah.
heard, okay? Which is, it sounds so fun, and it is. It is.
No.
4 times negative 3 would be negative 12. You say, Coach, how do you do A times C? Well, this is A, the B is 1, and the C is negative 3. So then when I factor, okay, I then set it up and say what two values at the end multiply to equal my a times c, or negative 12, but add to be equal to 1. And you would tell me that it's what?
Negative 4 and positive 3.
Just flip the signs, I think you've got it. So be positive 4,
Positive 4, negative 3.
negative 3. Good. And what do I put at the beginning here? Well, because of the fact that a is greater than 1, we put 4x in for both of these values. Okay? The last part is, can I take anything out of 4x minus 3? No, because I can't take anything out. That's set in stone.
Take a 4 out of
I could take out a 4 at 4x plus 4 to get me what?
X plus 1.
X plus 1. And then we multiply that by 4x minus 3. And there we are. But then afterwards, I got to put what in for x? Tangent back in. So we just say tangent of x plus 1 multiplied by 4 tangent of x minus 3, and there you are. That's how you factor.
You do that different.
Don't you have to leave a
Say that again, Noble.
Why is
I
that?
put it.
You don't have to do it that way. I always look at it and say, okay, if I put x in for tangent, I look at this and say that's a little bit better for me to try to factor. Some people can factor by looking at this and say,
So like,
instead of an x, it's the same thing. I'm just putting tangent in. But I like to put x in for tangent, and that way it's a little bit easier. And then at the very end, when I factor it, you just put tangent back in wherever you see the x value. Okay?
Don't you have to leave that 4 outside of the
Traditionally, yes, but with the a times c method, you do not. Okay?
How do you write this?
B.
Like this right here.
No,
So
the first,
But
like,
how do you
4x
set it up?
squared plus 4x
4x
minus
plus
3x
x
minus 3. No, you
Replace
group
the
these.
tangents with the x.
So what's the first one? What's the
It's
That's just another problem how we factored it. We'd said it was what? Secant plus 1 and
Oh,
secant
that's
minus
the
1.
difference.
It's just a whole different problem. These are just strategies right now.
Okay.
Not like problems, but just strategies.
I
Okay?
like this.
Alright.
But you skip some steps.
Did I skip some steps from what y'all do?
That's from the way I was taught, but that was a long time ago.
Do you remember what you did? Because there's other, I think Mr. Washington does it just a hair different, but it's the same type of process.
Yeah,
That's
I just group it differently. Like,
Okay, cool.
so I would put it back in as 4x.
Yeah, bro.
Put it back in.
that
4
makes sense.
x squared
Yeah.
plus
A little bit.
x minus
That's a little
3.
tough. We're kind of pulling from
Right.
algebra a little bit, so we'll practice that a little bit more.
You take 4x here. You said equal to 0. X plus 1. Nope. That's what you got, right?
Yep, that's right.
You take negative 3 from here, and if these are the same, that's how you know it's right. And it gives you the 2.
I see what you did. I like that. Rocking.
It just
Boom.
seems simpler than that.
Finding a better way. I like it. Did y'all see that? I don't know if that helps at all. He does the same exact thing. It's actually the same process. The only difference is instead of putting the 4 and negative 3 on the outsides, he puts the 4 and negative 3 as the two x's. Plus 4x minus 3x. And then he groups them together, takes out what's in common, and then rolls that way. Whatever way works for you, I'll take. I really will. I'll take it. This is just something that helps me. I don't like check and guess, I'll be honest. If you do check and guess, that's good on you. For me, I usually guess wrong. Just me. I usually guess wrong. So I like something that was a little bit more, hey, this is where we're headed. Okay? Questions? All right, I think we've got, boom, boom, boom. Yes, okay, so here's what I want to do with this time. We get out at 10:05. Okay, perfect. We got about 9 minutes. Let's do one more on this. I want to do one more. And then afterwards, we'll take it, kind of go from there. Okay. All right. Notice on example 6. What's the problem on example 6?
Cosecant squared x minus cotangent x.
It's the same thing we just did.
Exactly. Except what?
Cosecant.
Yeah, we're not speaking the same language, right? We have two things that are going on. How could I take cosecant squared and make it speak the same language as my cotangent of u, or cotangent of x? Jackson.
Set it, you just make it 1 plus cotangent squared.
Good, because 1 plus cotangent squared is cosecant squared, right? Y'all follow me? Because of my what identity? Diagonal identity, right? And when it's squared, then I'm looking and seeing, can I take it to where it's now speaking the same language? Well, if I have 1 plus cotangent squared of x minus cotangent of x minus 3, I'm now speaking the same language, right? So, no, but what could I do with cotangent of x instead of working with that if I'm trying to factor this? What could I change cotangent to? It's kind of what we were talking about earlier. We could put what in? We could just put x in. Cool? If you wanted to make it easier on yourself, we could just say up on top, cotangent of x equals x for just a second. So literally what happens is that this becomes x squared, and we're left when this becomes just x. All right, so we could simplify this to make what? Yeah, negative 2 at the end, because 1 minus 3 is negative 2. So this would be equal to x squared minus x minus 2. Okay, that's where we're at. Okay, someone help me, just by a raise of hand. What could I do to factor out x squared minus x minus 2? Can we take anything out? Are we using a times c here?
No, you're just gonna factor it.
Just factor, right? Basic factoring here. Good, so this would be x minus 2, because two numbers that multiply that equal negative 2, but added equal negative 1, that would be x minus 2 and x plus 1, right there. And instead of putting x in, what do we put in? Cotangent. So we would say cotangent of x minus 2 and cotangent of x plus 1. Questions on that? Okay, do you see how we kind of use some of these strategies to help us? You may. Let's do this. Let's go to number on your homework. Let's do this because I'm going to hopefully try to help with doing some homework ones here. Try number 1b and 2a. So 1b first, do that one, and then go to 2a and see if you can kind of get down 2a. And if you need some help for about the next 5 minutes or so, I want to try to help you with those questions there. Okay.
You just stole my tickets.
1b and 2a. 1b and 2a.
Actually, just stole my tickets. Just took.
Which language?
If I'm ever kind of questioning, sine and cosine is always good. So on number 2a, or 1b, I'm sorry. I know that the question has like cotangent and then sine. If you see something where you're like, man, I don't know what to speak in, what language to speak in, put it always in sine and cosine when in doubt. So if I don't see something that's squared, put sine and cosine in, and then see if you can simplify from there. Okay? Does that make sense on this? Kind of comes back from our first unit. Just a little bit more intense. Just take some practice. You'll have all of the identities that are there, right over here on this side. You'll have these. The big thing is just trying to manipulate this and some algebra concepts to be able to help you better. So, like over here, if I was talking in terms of this, right? How could I simplify this side to kind of help us cancel?
Might as well just give them back.
Dude,
You took my tickets. I saw
put
you.
it like terms on those.
You
Exactly right.
actually
So in terms of signing,
Where else did they have lunch?
it's always a good strategy to help us out with that. You know what I mean? So what could I do with this to kind of put in terms of signing cosine?
Hey, wait, Jackson is back.
True. Is that in terms of signing cosine?
You actually took my tickets.
That makes sense.
Where are they?
Wait, we
Yeah.
need sine.
You get cosine.
Oh, wait, oh.
Actually,
That's
stole
cosine
Yeah.
or sine?
Give back. You said 2A.
So then if I show that, it'd be cosine over sine, right? And then tangent would be what?
Hey, give them back.
It'd be sine and cosine.
Give me my tickets.
And then we're gonna, we might have to cancel on that, right? And then simplify. And then
I did not have
kind of
8.
So it'd
Oh
be
my
like
gosh.
sine over cosine
I had
plus
20
cosine
plus.
plus sine.
So yeah, cosine over sine. The sine, if it's cosine over sine, and this is sine over 1, what can cancel? So right here. This is where you're at, right? What can we do on just this part here? Yes, and specifically because we can multiply, right? If we have one both top and bottom, what can we do? And we do the same on that side. Well, all we're doing, we don't know what we're setting it equal to. You're just trying to simplify it. These are just strategies to simplify. Okay? Does that make sense? Let me know if I can help. Y'all get the next one? 2a. Yes. Pull out that tangent. Does it say factor? Yeah, so those ones you're factoring. So when it says factor, you could just simply pull out what's in common and proceed on there. We're on this one.
You know what I'm saying?
Those are on the homework.
But how do you like isolate that one?
I think it's just 1 minus sine
The
squared.
parentheses are on the one? Or not?
It's just 1 minus sine squared.
Oh, you're right.
And then I just cancel
And
that.
1 minus sine squared is equal to something. There you go.
Yeah, cosine.
This right here, though, would be.
So,
Oh,
sine
alright.
squared.
In fact, I'm going to put it would be left as inside of 1 minus sine squared.
You were not going to.
And that would be positive.
What do you mean I'm not?
And 1 minus sine squared is my friend.
You're making out of those. Why? These are not all the ones I have.
Trey, are you
I'll
saying
take
where
you
is
something.
So,
Stop.
sine squared.
I will take
Minus
you.
factor.
Why? Because
And then
you stole my
then it would, you'll be able to.
ticket.
Hey, this is gonna take time, y'all. I would